Hello, everyone. Welcome to the talk on Consul Service Mesh on AWS ECS, hosted by two presenters, Paul Glass, engineer on Consul team, and myself, Usha Kodali, product manager for Consul at HashiCorp. Thank you for your time and interest in the topic. And here is the agenda. We'll have a quick intro to ECS and Consul Service Mesh, followed by demo and the roadmap. So we'll explore quickly what is Amazon Elastic Container Service. It is a container orchestrator and is very similar in terms of functionality to Kubernetes or Nomad. But what differentiates ECS is its emphasis on simplicity compared to Kubernetes. And what does this process look like on AWS? The image is stored in Amazon Elastic Container Registry. It's then submitted to Amazon ECS. Then user can decide where to run it. And ECS provides two launch modes, EC2 and Fargate. Fargate is a serverless compute engine and is one of the most popular options. Consul supports both Fargate and EC2 as launch types using AWS ECS Terraform module. And in the future, AWS CDK module will be available as another option for automation, emphasizing it's the workflow and not the technology. Now let's take a look at a sample application running on ECS. Here, our sample ECS cluster, it's populated with two microservice applications, each application running its own ECS task. Now let's walk through the request path for a simple action. A user is accessing their profile via website, and the website is loaded via the ALB, which is sitting directly outside the cluster, as you see. Once it has taken you to the task running on the front end, then it still needs to load the profile. And to do so, it has to make the API call over to the service, hosting the profile service, which is routed through the internal ALB. Now, this represents a standard way of running things on ECS. If you take a step back and look at this architecture, depending on the needs of an organization, there might be some certain aspects they'd like to augment. Perhaps there's a mandate to bolster security, gain more insight into their performance, or wanting a better control over the flow of traffic. And this is where Consul Service Mesh fits in. And some of the use cases would be long-lived sockets. While this use case could be solved using network load balancers, but it comes with an additional cost. And another use case is service failover for resiliency. And we'll learn more on this. We'll hand off to Paul, who will walk us through Consul and the service security aspects, and also the failover use case. Paul?
Yep. Thanks, Usha. So this is kind of what it looks like to run service mesh applications on ECS today. You have your application running in a task, which consists of a few containers. You have your application container, your Consul client container, and your Envoy proxy. Kind of separately, you have an ACL controller. Basically, this is responsible for provisioning the Consul ACL tokens that tasks need to authorize themselves and register with the Consul server when they start up. In this particular example, and in the demo, we'll show Consul servers in HCP, HashiCorp's Cloud Platform, where you run managed Consul server clusters, but you can use Consul servers in EC2 or elsewhere. Really, it supports any Consul server deployment. And just zooming in on kind of the communication. So you have TLS encryption and GOSP encryption for all the Consul, to secure all the Consul communication. You'll have the Consul access control system enabled to kind of enforce authorization for all the Consul servers, and you'll need to provide those tokens to ECS tasks, and that's what the ACL controller makes very easy. And then you have mutual TLS to secure service-to-service communication. This is kind of a brief look at what the Terraform looks like. So on the right, we're setting up an HCP Consul cluster in Terraform. So you create the cluster, and then there's a couple of resources, a couple of secrets we grab and store in AWS Secret Manager. So there's the Consul CA cert in this case and the gossip encryption key that I'm showing here. On the left, we have our mesh task module, and what this does is create your kind of mesh-enabled ECS task definition. So you give it a list of container definitions. So in this case, I have like an example server app, and what mesh task will do is add the additional containers that you need. So the Consul client and the Envoy proxy container that I showed earlier. And then there's a few additional options. You specify the Consul server location, and you've got a handful of secrets at the bottom. So I'm just showing how you kind of connect the mesh task to these secret manager secrets to provide tasks with the Consul server CA cert and the gossip encryption key. There's an additional secret there for the Consul client token, and that comes from the ACL controller. And I don't really have time to show any more in the lightning talk, but there's some more Terraform that we'd set up. So there's a VPC to house the tasks, an ECS cluster where they run. There's a peering connection to connect the VPC to the HCP Consul servers, ECS services, and an ALB. If we have more time, I'd certainly dive into those. And then a quick demo where I'll kind of show Terraform running, and then kind of what you see in ECS and some intent, the Consul intentions and a failover scenario or a failure scenario. So this is pre-recorded, so hopefully this is fine. Yep, so I'll run Terraform first, and actually I've already created everything, so Terraform won't make any changes, but this creates the HCP Consul cluster that I showed, as well as a couple of mesh tasks. One for a client application and a few instances of a server application. So there's the application address that'll show in the browser later. There's a Consul server address, so that's an HCP. And then there's an ACL token that I'll use later in the demo. This is the ECS cluster. So we have a couple of services. So these are the ECS services that schedule tasks for you. There's one instance of the client and a few instances of the server. And then there's our ACL controller. If I jump into one of these, I just want to show the containers that the mesh task adds. So at the top, you have Consul client, and then you have the sidecar proxy. So that's Envoy. So mesh task automatically added those into this task. And then you have your application container. And then there's one additional container I didn't mention, mesh in it. This runs briefly at the start of the task to register this instance of the service with Consul. So whenever your task starts up, it is automatically registered into Consul. So jumping into the Consul UI, here's the two services. I have one instance of the client, 3 instances of the server. And I'll dive in here. This shows the upstream relationship. So the client's talking to the server, and there's a default deny intention there, which is the red arrow. And we'll kind of see what effect that has in a minute. So here's the 3 instances of the server app. And for the demo, I just want to point out their IP addresses. Those will kind of have a little bit of a failure scenario, and I want to show which server instances it's able to access. So there's a 10.0.1, a .2, and a .3 there on different subnets. So these are checks for one of the server instances. There's an agent check. There's a TTL check that I'll use for the demo. There's a health check for the Envoy container, and an alias check to kind of glue the proxy and the app together. If any of these checks fail, what Consul will do is stop directing traffic to this instance of the application. So we'll kind of prove that in the demo later. I'll fail the TTL check and then demonstrate that. But first, let's take a peek at the application we're running. So I need to refresh. And yeah, it's having an issue. So what it's trying to do is this is the client trying to reach one of those server instances. So it does that through the Envoy proxy. So that's what that local host address is. It's reaching the upstream to the proxy. And of course, it fails because there is a default deny intention. So we're going to fix that. So I'll click on it. Connection denied. So I create it. It's added. And we go back and kind of immediately the client can reach one of those server instances. I'm going to refresh a couple times to get this particular IP address, just showing that it's reaching this instance of the server. So it's reaching at 10.0.1 there. And what I'll do next is demonstrate a little bit of a failure. So I'll jump into this instance. So there's that 10.0.1 address that the client app was able to hit. I've got this TTL check, and what I'm going to do is manually fail that check. So this would kind of simulate any of those checks failing, or if you had like an HTTP or TCP check defined in Consul to health check your application. So I run the script. What this is doing is just logging into the Consul client container, and it's making a Consul API request to fail the health check. So there it is, it's failed. If we jump back to this, I'm going to refresh a few times. And what we want to see is that it does not reach that 10.0.1 address because it's been marked unhealthy. So we got a 10.0.3, a 10.0.2, refresh a few more times. And yeah, we're not seeing that 10.0.1 address. So we'll just resolve that real quick. So I'll pass the health check and show that it's able to reach that server instance again. So I pass it, same thing. Log into the Consul agent, pass the check. There it is, it's passing. And we refresh a couple of times and it's able to reach that instance again. So just a quick demo of how Consul kind of automatically handles a failure scenario.
So,
and that's it for the demo.
So Paul, what if the service is across a different region?
Yeah, if you have different regions, you probably have one Consul data center per region. So that'd be two kind of Consul server clusters, and you'd want to federate them. So you could do that via WAN gossip or mesh gateways. And from there, you have that kind of solves routing and information sharing between the data centers. And then from there, you can leverage Consul DNS to kind of inform applications of which instances are kind of healthy. And you can actually tell it to do you can actually set up failover to the nearest healthy instances or to like a particular data center. It's a little too much to get into here, but there's some great HashiCorp Learn tutorials for that.
Perfect. Now we'll get on to the
See if I
roadmap.
can.
Yeah. All right, coming to the roadmap, GA release will support using ECS health checks instead of Consul native health checks that Paul just demonstrated, and enhancements for graceful startup and shutdown of tasks in ECS. So that would be the primary focus for GA, slashing on to what we have already supported in beta. And with our partnership with Amazon, we will have CDK integration for Consul to automate the deployment. We're also looking at supporting all gateways natively. You can see how existing customers like Comcast and Tide have already leveraged these gateway functions for multi-region as an example. And we'll also be supporting some enterprise features such as namespaces, network segments, and admin partitions. We are looking at integrating with Vault to enforce security best practices as well. And the next slide here, this link, you can actually learn more about how Comcast is using Consul on ECS in this recorded webinar, and link will be copied into Zoom chat session as well. So you can have it for reference later. And the next slide here, we are sharing all the links again in the chat. Here are more resources to learn about Consul. Highly encourage and recommend the easy to learn tutorial on serverless Consul service mesh with ECS and HCP. Here you'll see Consul on ECS in action using HashiCorp Cloud Platform. Again, the links will be posted in the Zoom session. And that's it for today. Thank you all. And
thank you.
Have a great day.